Okay, so we're now talking about factoring polynomials. And some of these, I think you've seen most of these actually, when you think about it. So method one is just the factoring of the greatest common factor. So just simply looking for the greatest factor and pulling that out. So as I look at, like, for example, number one, as I look at number one, I notice that both of these have a 6 in common, right? If you think about common multiples or common factors, they both have a 6. And then the highest x that they have is x squared. Now, when I do this, I always think of like dividing it out. And actually, I'm going to write that out for you just so that we're on the same page here. The way that I like to view this, I wish I could move it over. The way I like to think about it is this way. I like to divide by 6x squared on both of them. Because what I'm doing is when I write it on the outside, remember, it's like you're saying, hey, if I multiply this back in, I need to get back to that original thing. So then I can see that 6 divided by 6 is 1, and x cubed divided by x squared is just x. 12 divided by 6 is negative 2, and then your x squareds cancel. So this is what would be considered factored form. On number two, I want to find the greatest common factors. And what I notice is that every single one of these has an a. So I can take an a out. And I notice that they all have at least an x. So this has the least amount of x's. So that's how I know I can only take one x out. And they don't all have 5, so I can't remove a 5. So I'm going to factor out ax out of each of these. In other words, I'm going to divide the ax out of each term. Whatever I divide out goes on the outside of my parentheses, and I can see that then these cancel. So then I have negative x squared plus 5x minus 5. Now, there are more proper ways, if you want to say, like usually we don't have a quadratic leading in when we're factoring in with a negative. So another thing you could do is you could factor the negative out. So we could have negative ax, and then we could have x squared minus 5x plus 5. So you can also factor a negative out too. So that's our first method, is just pulling out something common. Oops. Okay. The second method is factoring by grouping, not my grouping, but factoring by grouping. This is actually the way that I teach a lot of students how to factor quadratics a lot of times, because it breaks it apart. As I look at this, what I'm going to notice is these are kind of already grouped for us, which makes it a little bit easier. But if I look at these two, what I'm going to see is that they both have x's in common. And when I look at these two, they both have 5's in common. So on the first set, I'm going to factor out an x squared. That leaves me with, I'm going to put it in black, leaves me with x plus 2. On the second set, I'm going to notice that they both have a 5 in common. When I factor out a 5, that leaves me with x plus 2. Now, I did that on purpose so you could see that, do you recognize now that these both have a common factor of x plus 2, which is in the black? So if I factor out x plus 2, then that leaves me with x squared plus 5. So I took a cubic with 4 terms and I factored it into 2 binomials, is what we just did. Number 4, you could try this one on your own. Pause the video, see if you can do it, and then I'll do it for you here. So here, if I look, I see both of these have a y squared. So I'm going to take a y squared out, leave me with y minus 1. On the second ones, I have a negative 3, leaving me with y minus 1. That way, by factoring out a negative 3, it changed this so that made these two match. So just kind of keep that in mind. Typically, whatever value, like if this is positive, pull a positive. If it's negative, pull a negative. That's kind of most of the time how it works. Now you can see that I have y minus 1, and then what's left is y squared minus 3, and then times y minus 1. And that's factoring by grouping. Now, the next part is reverse factoring by reverse. And this is where I believe like in like your 9th grade year when you first learned this, I think many teachers did like, I think it was an X where they'd say what multiplies together to give you negative 14, but adds together to give you negative 5. And then that was your goal. So like negative 7, and positive 2 would multiply together to give you negative 14, but add together to give you negative 5. And so that's how we know that it then is X and X, negative 7, positive 2. On number 6, as we look at this one, again, it's as soon as this first leading coefficient is a 1, then I know it's just X times X. I don't have any other options there. And then I need to know what multiplies together to give me positive 12, but adds together to give me negative 7, and that would be negative 3 and negative 4. On number 7, because this leading coefficient is not an 8, or is an 8 and not a 1, it leaves a lot of choices, okay? And so we want to know what multiplied together. We got to figure out how we can break it apart so we can get negative 10 and a negative 3. So as I think about it, a couple things. I'll show you two different methods. Because 3 is prime, it right away tells me that I'm going to have a 3 and a 1. But because it's negative, I could have negative 3 and positive 1, or positive 3 and negative 1. And I just have to work to find out which one it should be. And then for 8, I could have 2 and 4 or 8 and 1. Now, because I want negative 10, I need to think about what would give me 10. And 8 and 1, if I'm just going to write in 8 and 1 here. If I put 8 and 1 here, I'm going to get 3 and 8, which will no way give me 10. So I don't see how that's going to work. Positive or negative, I don't see that working. So let's see if I can just erase those parts. And then, so instead, what if I think about 2 and 4? If I put a 2 in here and a 4 in here, I get 12 and 2. Could I make 12 and 2 give me negative 10? And your answer is yes. I could have negative 12 plus 2. So then I just add my x's in there. That's the guess and check method. I'd also like to share with you another method that is by grouping. I just call it split the middle. And not everybody shows this, but if you don't like the guess and check method, like what we just did, or if you get stumped, you can always look at splitting the middle. So I'm going to show you that method quick. So our problem is 8x squared minus 10x minus 3. So I'm going to do the same problem. I'm just going to show you a different way. So we're going to ask ourselves what multiplied together to gives you negative 24, but adds together to give you negative 10. Okay, multiplies together to give you negative 24, but adds together to give you negative 10. So when I think about negative 24, one of the ones that comes to my head is 4 and 6, right? But 4 and 6, I need one positive, one negative. So that won't work. So what about 2 and 12? So 2 and 12, if you remember, think about our guess and check method. This is also where we came up with that. 2 and 12 will give me 24. And if I make it negative 12 and positive 2, I'll also get that. So now, here's why it's called split the middle. I'm going to split the middle term into two terms. I'm going to call it 2x minus 12x. Have I changed it at all? No, I've just changed the way it looks, but I have not changed the value. So I have 8x squared plus 2x minus 12x minus 3. My middle terms, I've just split it up. Now I can go back and do factoring by grouping. I can look for common things in each one of these sets. So if I look at the first two, I'm going to notice I have a 2 and an x. When I factor out a 2 and an x, it leaves me with 4x plus 1. When I look at the second two, these two here, I'm going to notice they both have a negative 3. So I'm going to factor out a negative 3. That leaves me with 4x plus 1. Now, do you see the common group? Do you see this piece we can factor out? So I can have 4x plus 1 times 2x minus 3. So if you don't like guess and check, or if you get stumped and you know it should be factorable, you can always split the middle. That's another method you can use. Then we have reverse multiplication, and there's special factoring groups. And these, honestly, I would make cheat cards. Like I'd make a little note card with these ones right here. Oops, I forgot to select here. With these, I would make a note card. Especially, I think the first three are good, but I think often we forget about those last three. They're just not as used as much. So I'll just run through one example of each using this method, just following what they have. Then if I have x squared minus 49, then that's going to be x plus 7 times x minus 7, because it's the difference of squares. On letter B, I'm going to recognize that this is a perfect square and this is a perfect square. So then I know that it is x plus 3 quantity squared. On letter C, I'm going to recognize again that this is a perfect square and this is a perfect square. So if I think about what it was originally, if you square rooted it, you get 3x, and then I'm going to have minus 5. And I know it's minus because of that sign. So 3x minus 5 quantity squared. Number 11 is the difference of cubes. 27 is 3 cubed. So then what that tells me is I can follow the pattern. And so this is x cubed and 3 cubed. So I can have x minus 3 times x squared plus 3x plus 3 squared, which is 9. And then finally, the sum of the cubes, I just like to note in my head that this is 2w squared then cubed. I like to think about it that way. And this is 5z cubed. That way I know that this is my A and this is my B, in case you struggle to see that. So look at what it would have been originally. So then what that allows is then I would have A plus B, so 2w squared plus 5z, okay, times, and then I'm going to have A squared, so that's going to be 4w to the 4th, because I'm squaring that A part, minus, multiply them together, so that gives me 10w squared z, and then the last term squared, so plus 25z squared. Okay, again, the differences in sum of cubes, that's one that if you don't remember it, write it down, make some note cards, and get those in your head, because that's going to be a small step in a bigger problem later on. All right, so factor by substitution. Okay, for this, factoring by substitution, the part that I see that's ugly is this. And so I'm just going to call this x. I'm going to let x equal 2a plus 1. What that does is now I have x squared plus 2x minus 24. Now I have something that actually looks decent and nice. And I can say, hey, I know how to factor this. X and x, and then what multiplies together to give me negative 24, but adds together to give me 2. And that would be 4 and 6. So positive 6, negative 4 would add together to give me 2, but multiply together to give me negative 24. Now I factored it, but remember, we said x is equal to 2a plus 1. So what I'm going to do is where x is, I'm going to plug in 2a plus 1. So then I have 2a plus 1 plus 6 times 2a plus 1 minus 4. Then this gives me 2a plus 7 times 2a minus 3. And then that becomes the factored form. Here, if we want to factor completely, this is where you're going to factor something, and you just got to keep looking to make sure you fully factored it. Okay, that's the key to the next stage, and that's going to kind of keep coming up as we progress through the course. So as I look at number 14, the first thing I notice is that they both have a 2. So I'm going to take a 2 out. That then leaves me with w to the fourth minus 16. Now, what you have to catch, and this is where the trick is do you recognize, do you see this as w squared minus 4 squared? Then that becomes the difference of squares. So then we can leave the 2 out in front, and then the difference of squares is w squared minus 4 times w squared plus 4. That's the trick to keep going. You have to keep going. On the second one, number 15, as I look at that, what I'm seeing is I'm seeing grouping. I see these two and then these two to group, if you can see that too. And so I'm going to group out and pull out an a to the sixth. That's going to leave me a minus 1. And I'm going to pull out a negative 64. That's going to leave me a minus 1. When I do that, I have a minus 1 times a to the sixth minus 64. So now we can see a couple things. Maybe what you see is maybe you see this as the difference of squares. And I could see that. I could totally see that as the difference of squares. Do you see that it's also the difference of cubes? And I suppose I could show it either way, but I'm going to go with the difference of cubes. Do you see how this could be a to the second cubed minus 4 cubed? Okay, that's just that piece. So now I have the difference of cubes. So now I have to apply the difference of cubes to this factoring. So I have a minus 1 still out in front, and then I have a squared minus 4 times, I'm going to factor out, and then it's a squared, so, or the first part squared, so then that's going to be a to the fourth plus, multiply those together, so 4a squared, and then plus b squared, or plus 16. Now from here, do you notice anything else? And one of the things that I'm going to notice is that this right here, this is the difference of squares again. So then I have a minus 1, and then I have a minus 2 and a plus 2. And then looking at this, do you see how this is a squared and this is 4 squared? But this term does not meet that. It's not 2 times 4a. So this piece is not the sum of squares. And so then as I look at this last piece, this last trinomial, I'm just looking at this wondering, can I factor it anymore? And if I think about 16, that gives me 2 and 8. That won't give me 4. 4 and 4 won't give me 4. And 1 and 16 obviously won't give me 4. So at this point, I don't see that being any more factorable. So I believe it's just a squared plus 4, or sorry, a to the fourth plus 4a squared plus 16. So on these, you got to be really careful and keep looking and keep digging into each part. And that does it. Thank you for watching again. Let me know what questions you have.